Hello, scholars! In this video, we will be exploring an evolutionary process known as selection. There are a few different types of selection, and we're going to start with the process of natural selection. So what is natural selection? Well, it's simply a major force of evolution. It's one way in which evolution can occur. And just as a reminder, evolution is a change in the traits of a population over generations. So this population of elephants has evolved over many, many generations, and possibly that evolution occurred due to natural selection. Natural selection is unique in that it's the only force of evolution that makes populations better adapted to their environment. And let's take a look at how that happens. In this scenario, we have a population of bacteria. Here is generation 1. And if you look at generation 1 of the bacteria, there is variation in the traits. We've got some non-resistant bacteria and some resistant bacteria. What are they resistant to? Antibiotic. Antibiotic is a chemical that can kill bacteria. So when antibiotic is introduced to the environment, most of the non-resistant bacteria shrivel up and die. The survivors tend to be the resistant bacteria. So what happens next? Well, these survivors reproduce. And in later generations, we have populations made up of mostly resistant bacteria. And you can see that the traits of the bacteria have changed from one generation, the initial generation, to the final generation. Here, the bacteria were predominantly non-resistant. Now, the bacteria are predominantly resistant. So the key points to this process are that traits have to be heritable. They have to be characteristics that are controlled by genes. Being resistant to antibiotic is due to a particular DNA sequence. There has to be variation in the initial population due to random mutations. There needs to be a selecting agent, some feature of the environment that's going to make certain traits better than other traits. In this case, the antibiotic was the selecting agent. Because of the selecting agent, certain traits become adaptations. They become helpful depending on that particular environmental change. And finally, we have differential reproduction. Organisms with the adaptation are better able to survive and reproduce, and thus pass on their adaptations to the new generations. And that is selection in a nutshell. So let's take a look at some examples of natural selection. The first example of natural selection is known as stabilizing selection. Let's say we've got a population of mice, and there is variation in their traits or phenotypes. Some are light, some are medium colored, and some are dark fur colored. Now, in the original population, most of the mice have the intermediate, the in-between phenotype. A few have the extreme phenotypes. Now, let's say that in the environment is stable, and the stable environment favors the intermediate phenotype. If you look at the ground here, this in-between color is similar to the in-between color of this mouse. Well, what's going to happen over time as a result of stabilizing selection? This is going to happen. Over time, the population is going to continue to favor that intermediate phenotype. So originally the population was distributed this way, and over time, even more of the mice will have that intermediate phenotype. As you're taking notes, you really only need to put this diagram into your notebook. You don't need all of this information as well. A second type of natural selection is directional selection. Here's the situation. We're going to start off with the same variation in phenotype in our mouse population. But let's say here's the old environment, which looks like the intermediate colored mouse. Let's say the old environment changes dramatically. It's gotten much darker. Well, here's what's going to happen to our population over time. Over time, the phenotype is going to shift. Whereas most of the mice used to have the intermediate phenotype, over time, most of the mice now have one of the extreme phenotypes. In this case, a darker color that makes them adapted to the new, darker colored environment. And this is directional selection because the phenotype moves in one direction or another. There's also disruptive selection. Say a mouse population. This time, however, the environment changes such that the environment is varied and patchy. We have some light colored areas and we have some dark colored areas. Well, how will this selecting agent affect the population? Here we go. As you can see, originally the intermediate phenotype was favored, but thanks to this patchy environment, both extreme phenotypes, the light and the dark, become favored by natural selection. Finally, we have a special type of natural selection known as sexual selection. And in this case, we have individuals of one sex preferring a particular feature of the other sex. In this butterfly example, we've got females who really like their males with purple spots. And because of that, the purple spotted males reproduce more successfully, and over time, we're going to find more purple spotted males in the population. Now, let's conclude with an example of selection that is not so natural. This is known as artificial selection. And in this case, humans are going to act as the selecting agent rather than the environment. And they're going to do this by breeding organisms that have desirable traits. These traits are desirable to humans. They may not be desirable to the population itself. And because of that, populations may not become better adapted to their natural environment, but the populations do become more desirable to humans. And one example of this is the corn that you eat. Modern corn is the result of hundreds and thousands of years of artificial selection. Back in the day, corn looked like this. It wasn't very edible, it wasn't very large, and it wasn't very nutritious. But thanks to selective breeding, we now have nice, juicy, delicious corn. And that concludes our exploration of selection, one of the major forces of evolutionary change.